Alright, so I'm just going to do a quick video starting to talk about chemical reactions. We're just going to cover balancing equations today, and then we'll work on that a little bit and then move into the good stuff. So writing chemical equations, obviously, you're going to have reactants on the left side of a chemical equation and products on the right side. Whenever you have a chemical reaction, whatever you start with, the atoms that you start with, you also have to end with those atoms, even though you have different substances. So you're going to have different compounds, but mass is not created or destroyed. So it's a rearranging of the atoms that goes on in the chemical reaction. So the arrow represents the reaction happening. Reactants are on the left, products are on the right. So a couple that you will be familiar with: rusting. Iron is reacting with oxygen and making iron 3 oxide. Hydrogen peroxide decomposes into water and oxygen. We'll use some of these. You might have heard of catalysts. Hopefully you're pretty familiar with these, especially if you're in biology. But a catalyst speeds up the reaction, but isn't actually used. The way that this works is that each reaction requires a specific amount of energy to take place. We call that the activation energy. And a catalyst provides a different pathway for the reaction that actually takes a lower amount of energy. So the catalyst lowers that activation energy, or the energy that it requires to start the reaction going, and therefore the reaction can happen faster. So it's not going to be used up in the reaction. These are some symbols that you should be familiar with. Obviously, the plus sign, the arrow. This right here is a double arrow. That's for reversible reactions, or reactions at equilibrium. We'll talk about that a lot more in AP chemistry. These symbols represent the phase. So if something's a solid, liquid, gas, or aqueous means dissolved. That just tells you what's going on with that substance. These down here talk about things that are going on for the reaction. So if you see a delta, that's what the triangle is, or heat above the arrow, that means that all we did to make the reaction go was heat it up. If you see the symbol of a metal above the arrow, that means that metal was used as a catalyst. So in this case, platinum was used as a catalyst. So a balanced equation is an equation that has equal amounts of atoms on both sides. So if you look at this, carbon and oxygen making carbon dioxide, you have 1 carbon, 2 oxygen atoms. On the right side, you have 1 carbon atom, 2 oxygen atoms. Even though you have different substances, mass is conserved. That's the important part here. Mass is conserved. So hopefully a lot of you know how to balance equations pretty well, but it does take some practice to kind of just get the hang of it. A lot of times you can figure them out, but sometimes we just stall out when it's easy, and so hopefully I can give you a system here that'll help. So the coefficients obviously are how we balance. We change the numbers of the compounds so that the number of atoms on each side will end up matching up. So here, well, for some reason that 2 already came in. If we got, that's, well, it's because it's all balanced already. I didn't want it to be balanced. But zinc and hydrochloric acid make zinc chloride and hydrogen gas. Well, to get everything balanced, you would see, well, let me just go ahead and write this out. Zinc plus HCl gives us zinc chloride. Sorry that my subscripts are continuing to not work. So here we see that we got one zinc over here, 1 zinc over here. That's good. But we have 2 chlorines and 2 hydrogens, and we only have 1 over here. Well, the cool thing is that the hydrogens and chlorines are together. We need 2 of each of those, so if you just put that 2 in front, now it's all balanced. So this is what you kind of, think through it first before you start putting down numbers, and it'll kind of help you with strategy. So this is my suggested strategy. Obviously you do it how you want, but this is my suggested strategy, and I'll actually teach you a way to do this in class when we get back. I don't want to do it over video, over using algebra to balance, and that can make things really easy if you just stall out. So start with metals. See a metal on each side, make sure they're balanced first. Then go for polyatomic ions. With polyatomic ions, you can actually pretend like the polyatomic ion is its own element in balancing, as long as it appears on both sides of the equation. If it splits up into its elements, then you can't do that anymore. But if you see the same polyatomic ion on both sides, you can pretend like it's its own element and kind of balance it as a whole. Then go to nonmetals, not hydrogen or oxygen. Leave those out until last. Then go to your hydrogen and oxygen last. For some reason, it just tends to work out better that way. Sometimes, now this is just a little helpful hint, sometimes it is helpful to write water as HOH to kind of see things. And if you're doing a combustion reaction, which we'll talk about that later, start by putting a coefficient of 2 in front of the fuel if you're struggling. So you don't just do that automatically, but if you're struggling, that's a good way to just kind of start out. So, hydrogen and oxygen react to form water. Well, let's write this. Hydrogen is diatomic, oxygen is also diatomic, and then it makes water. So how do we balance this? Well, there's no metals. There's nothing besides hydrogen and oxygen, so that's what we're going to go to. The hydrogens, those are good. So now we're just going to look at the oxygen. Well, we got 2 on the left and only 1 on the right, so that means I got to put a 2 here. Well, now my hydrogens are messed up, so to fix that, I put a 2 there. And now you'll see it is all balanced. Alright, so here, I invite you to pause, try it yourself, and then see how this goes, but I'm going to go ahead and work these out. So A, you have hydrogen and sulfur, not diatomic with the sulfur, makes hydrogen sulfide. Sulfur has a -2 charge, so you gotta have 2 hydrogens. And look, it's perfect the way it is. B, iron 3 chloride, which means you have 3 chlorines and calcium hydroxide. Calcium has a +2 charge, so you gotta have 2 hydroxides. Makes iron 3 hydroxide and calcium chloride. So start with the metals. We see iron is good, we see calcium is good. So what we need to focus on are the hydroxides and the chlorides. Well, if you'll notice, they swap 2s and 3s on either side. So you want to find the lowest common multiple here. So if I multiply the right side of the hydroxides by 3 and the left side by 3, the right side by 2, that'll work it out. So 3 and 2. Now I got 6 of each. Then I'll look at the chlorines, do the exact same thing. Put a 3 over here and a 2 over here. Now those are balanced, and if you look, the metals automatically balanced out. So everything is good now. On this one, you have aluminum reacting with oxygen to form a protective coat of aluminum oxide. Aluminum has a +3 charge, oxygen has a +2 charge, so you got to do one of those numbers. Alright, so start with the metals. Obviously, the aluminum would be the first place to go, so you put a 2 here. Well, then you're looking at the oxygen, so you're like, oh man, I just messed everything up by starting with the metal. So obviously my system is not a 100% perfect system. Sometimes you're going to run into issues like this. So sorry for that, but most of the time my system works. So in this case, you actually want to start with the oxygens, because aluminum is by itself. When you see something by itself like that, always save it for last, because it's really easy to just put any number you want in front of it. So in this case, we're going to put a 2 here and a 3 here. We're switching the numbers, that way we got 6 oxygens. Now I have 4 aluminums, so I just put a 4 there, and that's good. You also want to check to make sure you can't simplify. We've kind of talked about that before, but if you can simplify anything, if I had like 8, 6, and 4, then I could divide everything by 2 to get 4, 3, and 2. So if you do something like that and it's bigger and you can divide it, go ahead and divide it down. Alright, calcium hydroxide. We've already had a little bit of that. Sulfuric acid, you have to know, and that's H2SO4, is going to calcium sulfate and water. Okay, so start with the metals. Calcium is good. And look at the polyatomic ions. Polyatomic ions are actually good with respect to the sulfate. Sulfates are good. So calcium's good, sulfates are good. What's not good is the hydrogens and the oxygens. So since this is all together, don't worry about the oxygens and sulfate. Those are fine. Just worry about the other oxygens. So I got 2 oxygens on the left and 4 hydrogens. I got 2 hydrogens and 1 oxygen. Well, it's a perfect ratio. So if I just put a 2 in front of this, now I got 4 hydrogens and 2 oxygens, and that works out perfectly. So that's what we want. Alright, on this one, we have calcium that needs to be balanced first. So I go ahead and I put a 3 there. Well, then I look at my polyatomic ions, and I have a 3 in front of this sulfate now, so that means I got to put a 3 in front of this one. I have 2 phosphates, so that means I got to put a 2 in front of this phosphate. And let's see where that got us. Oops, I'm going to put my 2 back. So I'm good on phosphates, good on sulfates, good on calcium. I need to look at my hydrogens. Well, I got 6 hydrogens and 6 hydrogens. It works out, so we're good to go there. A lot of times you'll find if you use the system, by the end, everything's kind of just worked out. And that's it. So we're going to do some practice of that this week, and I hope that that helps you.